Newton's second law states that rate of change of momentum is directly proportional to the force applied. This is definition. Children, in physics, rate means by time. In physics, rate means by time. Okay. Change in momentum. Change in momentum means final momentum minus initial momentum. Okay. Final momentum means mass into final velocity. Initial momentum means mass into initial velocity. Because yesterday we studied that momentum is equal to mass into velocity. Okay. Final velocity means final momentum means which has final velocity. Initial momentum means which has initial velocity. Means imagine a 2 kg body is there. Initially it is moving with 5 meters per second. If you apply force on this body, then it will change to 10 meters per second. This is called initial velocity, this is called final velocity. Mass into initial velocity is called as initial momentum. Mass into final velocity is called final momentum. Okay, mv minus nu is called as change in momentum. Okay, I hope you understood all of you. I hope you understood. Change in momentum means final momentum minus initial momentum. Okay, final momentum minus initial. So what Newton said means rate means by time. Change in momentum is directly proportional to force applied. So F is equal to okay, F is equal to, if you take M common, V minus U by T. Okay, what is V minus U by T? V minus U by T is called as rate of change in velocity. Rate of change in velocity. Rate of change in velocity is always acceleration. Always try to remember, rate of change of velocity is always acceleration. So F is equal to ma is the formula. This is it. This is it. F is equal to ma is the formula. Rate of change of velocity. Rate of change of velocity is acceleration. Rate of change in momentum is force. Rate of change in momentum is force. Okay. So F is equal to ma. F is equal to ma. All of you try to understand. Hope you are copying. Next, so next, so as the definition goes, Newton's second law definition goes that rate of change of momentum is equal to force. So F is equal to, if you take M common, V minus U by T. So F is equal to ma. Okay, and F is equal to, this I told already, kg meters per second square. Instead of saying kg meter per second square, we'll say 1 Newton. And I also told 1 Newton is equal to 10 to the power of 5 dynes. How you will get 10 to the power of 5 dynes also I showed you. 1 kg I said, 1 meter per second square, isn't it? 1 kg I showed you 1000 grams. 1 meter I showed you 100 centimeters into second square. That is 10 to the power of 5 grams centimeters per second square. So 1 Newton is equal to 10 to the power of 5. This whole thing in CGS system is called dynes. Okay, so 1 Newton is equal to 10 to the power of 5 dynes. And also, apart from this, dimensional formula. Yesterday for momentum also I told you dimensional formula. Mass into velocity is, this is m, and this is meters per second mlt minus 1 I told you. And the dimensional formula for force. What is the dimensional formula for force? Mass into acceleration. So m, acceleration means meters per second square, isn't it? Meters means L, second square means minus 2. Dimensional formula for force is mlt minus 2. Dimensional formula for force is mlt minus 2. Don't ever forget that. Okay, I'm telling all the points again. So rate of change of momentum is called as force, and 1 Newton is equal to 10 to the power of 5 dynes, and dimensional formula of force is mlt minus 2. And the force is a vector quantity. What is vector quantity? Which has both magnitude and direction. Okay. Since acceleration is rate of change of velocity, is in rate of change of displacement. Okay. Displacement is vector. Velocity is vector. Acceleration is vector. So force is also vector quantity. Don't forget, F is equal to ma derivation from Newton's second law. How you got it? I showed you today. Okay, so how you got it? F is equal to mv minus mu by t, where if you take m common, v minus u by t, that is equal to m mean. Okay, some numericals will do. First numerical. Five numericals I will do. Five numericals I will give to you. You have to say, okay, just listen. Find force when body moves, when 2 kg body. 2 kg body moves with 10 meters per second square acceleration. Simple sum. F is equal to ma. So this is 2 I told. This is 10 I told. So answer is 20 Newton. Directly you will get answer 20 Newton. Directly you will get answer 20 Newton. This is simple sum. Basic sum. Now using momentums we will do some sum. Using momentums. Okay. One more sum later. Using momentums. Second sum. Find force if body of 10 kg moves with initial velocity 2 meters per second, attains final velocity 5 meters per second in 2 seconds. Like this also they can. So children, we know F is equal to m a, that is m v minus u by t. Acceleration formula, never forget v minus u by t. So 10 kg, v is how much 5, u is how much 2, time is how much 2. 2 5s are 5 3s are 15. 15 Newton is the force. If momentum is involved. If momentum is involved. 15 Newton. Okay, mv minus mu by t. Like this only. One more. Find force. Find force if body starts from rest, attains final velocity of 18 kmph in 2 minutes. Like this also. Of mass, body of mass is 10 kg. Of mass 10 kg. Okay, here. So children, here always you have to convert kmph to meter per second. And body starting from rest, always remember body starting from rest. Initial body starting from rest, if they have given initial velocity is equal to 0. Never forget. Okay, so F is equal to m v minus u by t. Mass how much they give 10. Final velocity is 18. 18 into 5 by 18. 18, 18 cancel 5. Initial velocity 0 because starting from rest. 2 minutes. 2 minutes means convert into seconds. Compulsory you should convert into seconds. So 10 into 5 by 120. 0, 0 cancel. So 5 by 12, that is 0 0.4. 2 means 1. 0 0.41 Newton. Approximately. Always rest means 0 initial velocity. And don't forget time you should convert into seconds. Okay. One more. Find final velocity of body moving with 10 meters per second of mass 10 kg when applied by a force of 100 Newton for 2 seconds. Final velocity I'm asking. Final velocity. Like this also question will come. Okay, whenever you have confusion, you should write first data, what they have given data. Okay, compulsory you should write data. If you write data, half of the sum will be completed. Only final velocity. Okay, what is the formula we have? F is equal to m p minus u by t. Substitute in the still the answer. Simple. Okay, so force is how much given? 100. Mass is how much? 10. V minus u is how much? 10 by t is how much? 2. Okay, so this will come up, this will go down. So 200 by 10. 200 by 10 is equal to v minus 10. This is gone. So 20 is equal to v minus 10. 10 comes here. V is equal to 30 meters per second. 30 meters per second is the final velocity. Like this, you can answer the questions. If you write the data, if you write the formula, you can substitute and get the subject. That's all. Okay. One more question. Five examples. Find force when 2 grams of body moving with 18 kmph attains 36 kmph in 1 minute. Everything I gave in different units. So what is our formula? F is equal to m v minus u by t. Mass how much? Grams to kgs by 1000. Never forget grams to kgs by 1000. Always you have to remember. Suppose if you don't remember, write somewhere and keep, so that you keep seeing it whenever it is possible. Okay. Final velocity 36 into 5 by 18. Initial velocity 18 into 5 by 18. 18, 18, 1, 18 2s are 2 5s are 10. Minus 5. In 1 minute. 1 minute means 60. So 2 into 5 by 1000 into 60. Okay. So this 0, this 10 gone. So answer is children approximately 1 by 6000 Newton. This is the answer. Okay. 1 by 6000 Newton. So everything is recorded, children. No need to worry. I will send it to you. And now I'll give you 5 numericals. You try to do on your own. 5 numericals based on this. I'll try to do on your own. Okay. Asha, don't worry. Everything is recorded for you. Don't worry. Now numericals I'm giving, children. All of you copied on the numericals. Everyone. Find force when everyone should do all numericals. 10 kg moves with acceleration of 2 meters per second square. If you don't do numericals, you will get confusion in higher classes, remember. When force of 2 Newton gives an acceleration of 2 meters per second square. Find force when 10 kg body moving with 36 kmph attains 72 kmph in 2 minutes. 2 minutes. Fourth question. Find final velocity if 10 kg body acted upon by 500 Newton force for 2 seconds, which starts from rest. Should try to do it. Everyone should try to do it. Okay, these are the numericals. 10 seconds time I am giving. First you copy, then we will do one by one. All the sums. 10 seconds I am giving. In this 10 seconds, you copy the questions first. Then I will stop the recording. Then we can discuss all the numericals. Please copy down, children. Yeah, children. I'm stopping the recording. You have to do each sum and